Hello and welcome to Postgres FM, episode 75. This is a weekly show about all things Postgres. I'm Michael, founder of PG Mustard. This is my co-host Nikolay, founder of Postgres AI. Hello, Nikolay. What are we talking about today?
Hi, Michael. Constraints.
Yeah. And specifically the 6 DDL constraints that Postgres supports. Yeah.
All of them.
We're back to basics. I love this kind of thing. So nice choice. Thank you.
It was my choice. Yeah. When I'm writing this Postgres Marathon series of how-tos and was considering how to create various constraints without downtime. Already covered checks and foreign keys and something else. Saying this, those who follow me closely now understand when exactly we record this podcast, right? Okay, because I write these how-tos every day. So about constraints in the same order as documentation describes them, but also let's talk about practical complications when you have a lot of data and a lot of TPS as usual, right? Because documentation actually doesn't cover these topics.
Yeah. Another thing I don't think the documentation covers is why do we have constraints? I guess it's so obvious, but I think it's worth mentioning that without these, we'd be in real trouble database-wise, wouldn't we?
Well, yes. So constraint. So we have schema, right? And without schema, it's not good to live without schema. And, no. Let's say no to NoSQL in general. Like maybe in some cases it's fine, but if it's financial data and so on, you need structure to ensure that data has good quality. And constraints is the next step. So you have schema, so you define column names, data types. And constraints is addition to all this to ensure even better quality of data. For example, you say no one can create more than 2 rows with the same value in this column. For example, email, and this is an interesting situation because usually people forget about this case sensitivity, right? Of text or varchar. And then you can you say if there is a row in this table referencing, like, for example, user ID. Means that such user should exist, and so on and so on. So it's all about data quality, but also sometimes for foreign key constraints, it also provides some automation. I would say limited, if you automation for how to handle, for example, deletes. Should depending rows in depending table, should they be deleted or not?
Yeah.
If like the main row is deleted, but this should be used with care. If you have million rows depending, and deleting one row might take a lot of time, and this is also not good, right?
Mm-hmm. Yeah, I feel like we've already dived into a few specifics around unique constraints and foreign key constraints there. But let's go. Yeah, I think you're right. I think the Postgres documentation does cover them in a really good order, and it starts with check constraints, which super flexible user-defined constraints almost, I'd say. Is that a fair description? Where we can choose, I think it describes them as a Boolean condition. So it's a check that returns true or false for each row that's inserted or updated.
Check constraint is usually very, how to say, underappreciated, right? It's underused in my opinion. And unfortunately, there you can define only some expression related to this table. You cannot involve different tables and subqueries and so on. But it limits the expressional power of it.
Right? Yeah, so we can define it we can have a check constraint on a column, or we can have it on multiple columns within
multiple
the table.
Columns is okay. You can say, for example, I don't know, like some of these 2 columns should be positive or something. Some crazy stuff. It's possible, definitely, and this is good. I mean, for example, if you want to say this is integer, but it should always be odd or even or something like that, right? You just define the proper constraint that will be, if you try to insert something which violates this constraint, you will get an error. And this is how you can achieve better data quality.
Yeah. When you say it's underused or underappreciated, what are the kind of typical cases you see for people?
Typical cases, people rely on ORM and perform all checks on. So usual 3 parts of architecture, front end, back end, and database. Usually people start with front end when they realize, and this is fair because you should check a lot of stuff, including all constraints should be checked on front to minimize feedback loop. Users should quickly see that something is not wrong. Ideally, before they make action, for example, filling some form, I would prefer seeing constraint violated and explanation how to fix it before I press submit. It's not good to press submit, wait some time, and then see, and then have some retries. It's very annoying. So constraint checks on front end makes sense a lot.
Mm-hmm.
But then people, if they use ORM, they prefer checking it in code because it's more flexible. And those who write the logic for Python, Ruby, anything, Java, they prefer writing it right there because it's their favorite language. But the thing is that if a company grows, project grows, and then you start having different users or applications, for example, someone directly works with data in some good UI, or you have another application written in different code, or in the same code, but skipping these checks. Implementation of constraints in application code is weak because it's not guaranteed. Only database can guarantee it. That's why check constraints or other type of constraints is good to have in database because it's the safest way to safeguard, right? So you're on the safe side and nobody will violate it unless there is a bug. Sometimes I saw some bugs and unique constraint violation happened, and it's good that, for example, check soon we will have a unique constraint corruption check.
Nice.
Yeah, but it's different story. So check constraint, you just say expression always should be followed, right? It should always return true. If it returns false, such insert or such update should be discarded, roll back, right?
And what is it worth us discussing what to do or how to add one retro? Let's say you're listening to the podcast and you realize you should have some of these in place, but you don't, and they're on quite large tables. How would you go about adding?
Let me finish about this consideration about front end, back end, and database relationships between them. I remember in 2004, I implemented. It's called MVC, right? Model View Control, a very old architecture, maybe not cool anymore. I don't know. But what I implemented there, I implemented a simple thing. So we define constraints on Postgres, and then we, at Bootstrap of our application, we analyze all constraints and build logic to inject it to form. And also with digital signature, because forms can be, it was long ago, but it's interesting. Forms front end followed constraints from database. It was cool. I think it's interesting idea. Probably it should be also rediscovered. I don't know. So you just define constraints where they should be defined in database, but then front end follows exactly the same logic, and you don't need to implement it twice, because if you implement it twice, you will have bugs, different logic, right?
Yeah. Well, and I've just realized there's another reason, which is handling concurrent sessions. So you might have a constraint. Let's say you have like an amount of stock of an item and it needs to not go below 0, or an account balance that needs to not go below 0. If you have concurrent transactions, you need them at the database level to make sure you don't end up letting a user take out more money than they're.
Well, exactly. You cannot check if such row exists and then make decision on outside of database. You need to make decision inside database. Yes. Yeah. So, but also what I'm talking about is having like main constraints should be in database, but you can mirror them in back end, front end. You can have automation, and it's good if somebody who develops ORMs or GraphQL or something would follow this approach, considering database side constraints as the main one, right? Yeah. So check constraint is not only very flexible, not super flexible, but quite flexible, but it also has this beautiful option to be created
not valid
in an online fashion, so to speak. Yeah, not valid. So you say not valid, quite confusing term.
Very.
Yes. So things to remember. When you create something not valid, it means that it's already being validated for all new writes. So this is super confusing part.
So it's kind of not validated on existing data.
Yes. So you cannot create not valid constraint and then insert something that violates it. This write will provide error. But what it does, not valid flag when you create a check constraint. It just skips long-lasting operation of full table scan to check that all existing rows follow this logic of the constraint.
Which is the default behavior when you add a new constraint.
Yeah. So if you don't think about it and just try to create a check constraint for existing large table, it will block DDL and DML, everything basically to this table.
Yeah.
And it's not fun. So what you should do, if you want to do it without partial downtime, do it in online fashion, you create 3 steps, not 2, 3 actually. My how-to yesterday was not full. So first you create with the not valid flag.
Mm-hmm.
Second, you understanding that all new writes already been verified automatically by Postgres. You yourself care about existing rows. You check existing rows are okay with this constraint. Just with simple selects, and if you found find some rows that that violate it, you probably want to delete them or update them to adjust the values depending on your application logic or on your logic, right? And then only then the third step, alter table, validate constraint, which will scan whole table, but this step won't acquire logs that would block your DML.
Mm-hmm.
It will block only DDL, but hopefully you don't alter during this. You don't issue any alters. Right.
That middle step's nice, and you can even do it in batches, I guess, if you want or need to. But I guess it shouldn't be a big deal.
Yeah, depending. But this maybe whole tables can also fine because it's just select, right?
True.
Well, if you update, yes, in batches, if you found many millions of rows that violated.
Oh goodness.
But this is it depends. But this 3-step approach is very universal, zero downtime approach, and it's great.
Well, what's the downside of jumping straight to step 3? Because you're kind of doing that if you think your data's fine. I guess is it in the real world you're more than likely got some
jump. If you want, if you just need to accept this risk, and then that's it. Of course, if you are 100% sure, step 2 is optional. Let's say. But also, as usual, if you issue alter with not valid, you also need low log timeout and retries, because it's still you still need to change metadata of the table. And if, for example, auto vacuum running in transaction ID wraparound prevention mode, processing your table, you won't be able to acquire log, and without low log timeout and retries logic, you will start waiting, and again. In this case, you will block everyone, even if it's not valid. It's not good. So retries are needed, and graceful alter needed, right? I wish there was such option like graceful, and you say how many retries and how low log timeout for particular operation should be.
That would be it would be a nice word. Instead of concurrently, it could be gracefully. Alter table gracefully.
Or concurrently, something like that. Because I think 99% don't think about it until they have many thousand TPS, and then they realize basic operation. It was always working fine. Sometimes probably not, but people okay, we had an issue lasting 30 seconds. Something was not right, but it's okay. And then we don't understand why, right? I mean, you blocked everyone dealing with this table for 30 seconds, for example, but kind of fine, and we live with it until it starts annoying you too much, and then you realize that you need a low log timeout and retries. It would be, it requires an effort, unfortunately, to have this, right? And if you're small, you don't care. But I wish it would be easier, something similar to create index concurrently or refresh multi-slice view concurrently, right? So also when you validate, I think if for example DDL kind of create index concurrently is happening, or to vacuum again processing, you won't be able to acquire this log. So you need also to be careful. But in general, if there you start waiting, it's kind of fine. It just makes your operation longer, but at least no DML transactions performing DML operations are behind you in line, right? So, I mean, this is also an issue with this final step, but it's not so harmful as it in the first step when you need to quickly inject this constraint with not valid flag. Yeah, so I think we covered it, right? So let's move on.
The next one in the documentation
I
is
think
not,
this should be hidden behind some, I don't know, concurrently or gracefully or
would be awesome. The next one in the documentation is not null constraint, which
Right.
the documentation points out it's probably one of the ones people are most familiar with seeing in schema definitions, but it's just a special case of a check constraint, which I hadn't thought of before.
Right, but unfortunately you cannot, well, you can already, but if you have check constraint not null, saying this column is not null, like logically it's the same as the standard not null.
Mm-hmm.
Same. But primary key needs the letter, right? It cannot use, but it can. Since Postgres 12, like
nice.
if you don't have not null constraint and you define primary key or redefine it will try to implicitly create not null constraint. But since Postgres 12, when you create not null constraint and you already have checked is not null, it will just reuse it, skipping full table scan, which is very good optimization. So you just create check constraint in this like 3-phase or two-phase approach, as we just discussed. And then you can rely on it when you're creating primary key, for example.
Mm-hmm.
Or you can define not null constraint explicitly if you need it for primary key or any other, I don't know, maybe your application wants regular not null. Relying on the existing check is not null. And then you can drop check and not null is still there and you skipped this unfortunate full table scan. While it's like I'm telling this because not null, creation of not null itself, Postgres doesn't support 3-step or two-step approach. If you want to create not null right away on existing table, existing column, it will need to scan whole table.
So we don't have not null, not valid. Yeah.
So yeah, this is like some nuances to keep in mind. Generally, my recommendation is to think more about check constraints. This is why I say they are underappreciated. They are good, and they support not null constraint creation since Postgres 12, not before. But it means all currently supported Postgres versions.
Yeah, true.
12 is already the oldest.
Let's move on. Yeah.
Yeah, unique constraint. Unique constraint. This is interesting. I don't know how much detail we should cover here. Before our recording, we discussed the case I discovered in 2017, and it's still so in Postgres 16. So, unique constraint. Physically, it relies on unique index, but it's a kind of implementation detail. You can say I want a unique constraint, and Postgres will create a unique index implicitly. And it's good that it can be done concurrently, of course, right? Because indexes can be created concurrently, which is good. That's it, basically. You create constraint, but I think you can say using, right? Create unique constraint using some index if the index already exists, or what? Maybe. Yeah, I don't remember in detail, but what I do know is that although unique constraint relies on unique index, it's not absolutely the same. So logically, again, it should be kind of the same, right? But you can have index without constraint, not vice versa. You cannot have unique constraint without unique index because Postgres needs unique index to support validation checks, right? So imagine we created unique index, but we haven't created unique constraint. One place where you can see constraint is needed is insert on conflict, right? If I'm not mistaken, right?
Yeah, I think so.
Yeah. So on conflict requires constraint to be present. And if you say you have a conflict, like for example, do nothing, you cannot, if you have index without constraint, you cannot say insert blah blah on conflict on this constraint because constraint does not exist. It will tell you explicitly constraint does not exist. But at the same time, Postgres has interesting, like I think it's logical bug, still not fixed since, and I reported it in 2017, and today I checked in Postgres 16, it has it still. If you try to insert multiple errors, it will explicitly say that constraint, and it will use index name, violated. So in one case it says there is no such constraint, and in another case it says this constraint exactly with its name is violated. Okay, so inconsistency. I think it's just a bug that needs to be fixed, and that's it.
That's funny. I'll link up the bug report as well.
Yeah, but honestly, from user perspective, I think it would be good to stop thinking about unique constraints and unique indexes as something like very different. I cannot imagine the case when we like they should go together. I think I cannot imagine like we have unique index, but why don't we have unique constraint in this case? I think they should go together all the time. That's it.
It makes sense.
In this case, there would not be any inconsistencies if when I create unique constraint, unique index is created implicitly. Okay, but why not vice versa? When I create unique index, why Postgres doesn't create unique constraint? I have no answer for this.
You can't create a unique constraint not valid as well, can you? So there's no difference there.
I don't think so. No.
The one thing they have like a change in recent versions.
Yeah, as always, maybe I'm wrong. I think I'm not wrong here. I'm checking.
I don't think so. No. The one thing that has changed with these in the last couple of years is in Postgres 15, we got this nulls not distinct option, which I still don't. I'd love to hear from people that have good use cases for these, but it allows you to specify that you only allow a single null value rather than multiple null values.
Now it's the biggest problem in SQL model, null, right? We discussed it. We have
a whole episode on it.
Right.
Yeah.
But why I think people might want null as like, according to this, how it's called, trinary logic, three value logic, true, false, unknown, right? According to this logic, null means unknown, and comparing one unknown to another unknown, you cannot conclude they are the same. You always say they are not the same. So the comparison should always yield to unknowns, or basically to another null. Mixing nulls and unknown is another topic. And this means that unique index, unlike primary key, of course, unique constraint, unlike unique key. Let's also introduce term unique key. Postgres documentation doesn't follow this term. Unique key, unlike primary key, allows nulls in the column or in multiple columns if it's multi-column index or constraint. But since they are not, like, we don't know if they are the same or not, we can allow multiple nulls. But historically, exactly due because of the problems with manipulation of large tables and so on. For example, before Postgres 11, we had, if we, for example, add a new column, we want default. It's like full table rewrite. We cannot do it. It was fixed in Postgres 11, not fixed. A great feature that you can define like virtual default, right? But we say default. We cannot say default. I don't want full table rewrite. I don't hold. So I say, okay, I will consider null as false, just in my application. All right. So before Postgres 11, null will be my false, and true will be my true. In this case, I'm breaking theory concepts here. Like null should not be considered as false. It's not right. But just I don't want this operation to be such nightmare. Like I have billion rows. Okay, null will be my false, and this leads me to the idea I want it to be like one value in index. That's why, right? So I to avoid the long heavy operations, I give null a special meaning, not as it was supposed to have. This is practice. It's not theory, right? This is usual, like in many industries. Theory was very good. We developed great concepts, and then you go like to construction, for example. Oh, this is how it's used. We didn't expect. This is how nulls are used, right? So some people use nulls, giving special meaning, and they consider as normal value. In this case, they might want index or constraint to say there should be only one row with null. This is but maybe there are many other understandings, but this is what I have from my practice.
Cool. In fact, you mentioned in passing there one other important thing about unique constraints is that they can be defined across multiple columns in the table as well. It can be single columns really common, but you can do it across multiple as well.
Okay.
Should we move on? Primary
let's
key
do.
Being special case again.
Primary key. Okay. So not null plus unique constraint, basically. This pair gives you primary key, but there can be only one primary key
That's the
on a
big.
table. So
Yeah,
I think
exactly.
we already covered. You need not null. For not null, you probably need implicitly or explicitly. You can do it yourself or just rely on it when primary key is redefined for existing large table, right? Like for small tables, no problem. Also, by the way, just this morning we had a discussion. For example, creating this concurrently. Should we use it for new tables? In my opinion, no, because creating this concurrently or these multi-step operations. In this case, you lose the good, beautiful property Postgres has: transactional DDL and ability to pack everything into single transaction. If you just define the table, follow normal approach. Don't care about this zero downtime stuff, and you will have single transaction, right? All or nothing. This is good.
Same for tiny tables. Anything
Yeah.
with like.
Oh well, yeah. Maybe like less than 10,000 rows. You don't care about. It takes like 100 milliseconds.
Yeah.
Let's go. You have single step. It's atomic. Great. But if you have large tables,
Yeah.
you need to redefine primary key and integer 4 to integer 8, for example.
That's the big one. Yeah.
My team and I implemented all the types of this operation, and we helped multiple companies, a few multi-billion-dollar companies, public companies. We helped them to convert integer 4 to integer 8. I know a lot of interesting stuff around it, but in general, you just need like not now, and we discussed how there is also tricks. If you Postgres 11 trick like default -1 not null, you can define right away virtually, right? You don't need even check constraint. But since Postgres 12, we rely on check constraint, but we remember primary key needs actual not null. And we also create unique index, and when we create primary key, we say using this index. This allows us to put primary key creation as final step into a transaction, which will probably swap something, right? Rename columns as well. And there, of course, you also need to think about log acquisition, retries, log timeout, like all this stuff. And it's, of course, if you have many, I don't know, like gigabytes, dozens, hundreds, maybe terabytes, and a lot of TPS, you need to engineer this carefully. I mean,
this is probably the most involved of all the things we're talking about, and I think it's probably too big to cover today. But there is a really good talk by Robert Treat that I saw that covers this in about half an hour in depth for people that actually have to do this kinds of thing.
I'm sure it's not possible to cover everything in half an hour because there are several methods. They have pros and cons, and there are many nuances. For example, foreign keys. So if you redefine primary key, you need to deal with foreign key redefinition, and it's also interesting. And auto vacuum running transaction wraparound mode can block you. And also, if you decide to mark a foreign key as not valid, and then you realize it blocks writes, or you just forgot to drop old foreign key and new rows after switch. So a lot of mistakes possible.
Yeah, please use big ints or integer 8s in your new tables.
Right away, yes. Or UUID version 7, 8. Timestamp based.
Or UUIDs, yeah. Cool. Foreign keys? Or actually, one last thing. Is it worth discussing like multiple? You can have multiple column primary keys. I guess that's obvious from the multiple column unique ones as well. But foreign keys.
I don't think it's something somewhat different. Yeah. So just you need to have not null on each column, participating in primary key definition. That's it. Unlike unique keys, of course. So foreign keys involve two tables, and creation of foreign key requires several logs to be acquired on both sides. Fortunately, and full table scan of both tables to ensure that values in referencing table are present in referenced table, right? So in this case, if you just don't care and like brute force approach, like define in documentation, just create it. That's it. Well, you have an issue because you are going to block. Probably not. I think log level there is not so bad than in previous cases we discussed check constraints, but you are going to block DDL for sure. Probably DML won't be blocked or will be blocked. Yeah, probably it will be blocked as well. I don't remember details here, although I wrote it a few hours ago. Check out my how-to. I specified all the logs and what you're going to block. But in general, you should care about it as well. And generally, under load, you shouldn't want to create foreign key in one step. You need, again, 3 steps. First, not creation with not valid, with retries and low timeout. Then you need to check, again, like with checks, Postgres will start checking new writes that inserted and updated rows, or deleted in this case as well, because if you
Very
delete
important,
yeah, and you need an index, but it's another story. So it will start checking to validate this constraint for new writes, but for existing rows, we're still not sure. So optional step 2 is to validate and fix if you see problems, potential violation, right? And then third step, you say alter validate constraint. Again, understanding that ongoing index creation or recreation or vacuum can block you, right? So yeah, also 3 steps. I explained in detail in my latest marathon post. So what else to say here? Foreign keys can be marked as, how's it called? Deferred, right? Am I deferred constraints, right? So when you have complex transaction, you might want foreign keys to be checked at commit time later, not at each statement time, later. And in this case, I don't remember again details. Several years ago, we had an issue. We worked with Miro and had issue with using pgrepack to fight bloat, and they use deferred constraints. So there is an article about it, how to use pgrepack if you have deferred constraints, and
nice.
It explains a lot of details. I will provide link. So Miro Engineering wrote it a few years ago. It was interesting also issue to address. What else? I think that's it.
I think on delete cascade is worth mentioning. Like, you can define at the point of constraint creation what you want to happen if you have a really common example is a table of blogs and a table of blog posts. If you delete the blog, do you want the blog posts to be deleted? Like, what do you want to happen in those cases? And that's the case where I think it's really important to mention that whilst when we define a primary key, we get an index, foreign keys defined on one table, their referencing column is not necessarily, we don't check that it's indexed as well. In fact, I've even read a blog post saying you shouldn't always index that column, but I think the cases that you should far outweigh the cases where you shouldn't. It is worth checking you do have indexes on those so that those deletes on cascade are efficient.
Right. I always try to avoid using this option, but I see people in quite large databases under large load use this deletion propagation or update propagation logic. But so two things here. You're right about indexes and Postgres DBA toolkit I have and Postgres checkup tool. They have reports to find
nice
you have
cases.
Foreign key, there is index, primary key on one side, you don't have index on the other side. So when you will need you probably don't need delete every day, but at some point, if you have it, it will be a sequential scan. Very bad, very slow. But this is only one thing. What if you're deleting a blog which has 1 million posts? I don't like it. I don't like this propagation with if we know that only low number of rows will be automatically deleted. It's okay. But if it's unpredictable number of rows, I would prefer having my own logic with asynchronous propagation of change with some batches and so on. So
makes sense.
Yeah. But I see people use it at quite large scale.
Makes a lot of sense. Cool. I think we're down to the last one. We made it to exclusion constraints.
Right. I always confused exclusion constraints with constraint exclusion, which was related to partitioning. But exclusion constraints is for time ranges, intervals, and you want to say my intervals should not overlap. So it's kind of advanced uniqueness, right? Maybe not uniqueness, but it's for spatial data, for gist, SP indexes, and so on. So you define, I say, I'm building some schedule. I cannot allow overlapping, or I'm like describing some, I don't know, like 3D world, and I have various shapes, and I don't want them to be overlapped. In this case, gist and its variation R3 will support this constraint and ensure that no balls, for example, or no cubes or something overlap in my space. So Postgres supports this kind of thing, which is good, but it's quite narrow for me. I don't see it often.
Yeah, very cool. I think I've seen it being used in examples where people are designing room booking apps or things like that. But no, not used it myself. In fact, it's a tiny little documentation entry, isn't it? So it's
time and space. Yes, but documentation is very brief here. I honestly don't have anything to say. It's like it's supported by some index, I guess, right? So an index you create with concurrently, or usually if you want zero downtime approach. I'm not sure if exclusion constraint can be created based on an existing index. It should be possible. I have no idea. So
it says, good point. I don't know. Let us know in the comments.
Yeah, but in general, as we I think we covered pretty well how 6 types of constraints, at least 5 types of constraints we covered, and how to create all of them without downtime. Just let's final part. Let's think how to drop them. Well, I think dropping is straightforward usually.
Yeah.
If it's unique constraint which is based on index, you probably just drop an index with concurrently, obviously, right?
Yeah.
Others, you just drop them, but you need low lock timeout and retries to be involved, because you need, Postgres needs to change table metadata, and during this, if it's blocked, it's not good. So again, low lock timeout and retries are going to help here.
What about altering? I saw a good blog post where people took one of the use cases for check constraints is, for example, we often say use text in Postgres. It's in a lot of recommendations to use text, and that not be kind of constrained on how long.
Not varchar, not char.
Exactly. Well,
this, strictly speaking, is not constraint, right? But in broader sense, it's constraint. But but
you could implement it with constraints.
Oh, exactly. Yeah, and I like it because you control exactly how and when it will be verified, and again, this is exactly why, again, check constraints are underappreciated. And I indeed prefer using just text without limits, not varchar n, but just text. And then if I need to limit, I use check constraint. I know how to set it up without downtime, and I know how to change it if I need to increase or decrease this limit. I know how to do it, right? And it's good. It's good. But
I think we only lose one. I think we only lose one benefit, or one optimization. Or I'm not sure if there is this optimization for check constraints. Let's say we want to relax the constraint from 200 characters to 300 characters. I think if you're using varchar, Postgres will handle that, knowing it doesn't have to recheck existing data.
Yes,
but that's the only downside.
If you increase n in varchar, it won't rewrite, and it won't scan even because obviously if you just increase the limit, existing rows already are okay with this rule, right? So I agree. And in the case of check constraint, I'm not sure if we have any.
I don't think so. Yeah. I've not heard of one. But we can do the 3-step process you mentioned. It's just,
right.
We can probably add another constraint and then drop the existing.
Exactly.
Yeah, great. Cool. Thanks so much, Nikolay. Thanks everyone for listening. Catch you next week.
Yeah. See you later. Bye.